In today's lesson, we will be constructing reflections, again using the count and graph and general rule methods. Your learning target says, I can use either the count and draw or the general rule methods to accurately reflect a figure. You should have this note sheet from me for your interactive math notebook, and we're going to start with our general rules this time. So if we wanted to reflect something over the x-axis and its ordered pair was in the form xy, what we would do is we would keep the x value unchanged, which makes sense because if I'm reflecting over the x-axis, I'm going top to bottom or bottom to top. I'm not shifting side to side. So my x-coordinate will remain unchanged, and because I'm going either top to bottom or bottom to top, my y will become the opposite of what it was to begin with. If we were to reflect over our y-axis, again in this format, that means that I'm shifting left-right. And so in this case, my x-coordinate will be the opposite of what it used to be. And because I'm not shimmying up or down, my y-coordinate is unchanged. Now things get a little dicier when we're talking about reflecting over just a generic vertical line. And remember, vertical is this way. It would be like your y-axis, but not that specific line. And so in this one, we're going to write that your x-coordinate is the same distance to the line of reflection but on the other side. And your y-coordinate will be unchanged. So what you're going to do is you're going to take your ordered pair, you're going to count to the line of reflection, and then count that same number on the other side and plop it down. Don't shift it up or down, just move it left or right. Same kind of idea for just a generic horizontal line. Remember, that is your side-to-side, kind of like your x-axis. So in this case, your x will be unchanged. Because you're moving top-bottom. And in this case, your y is the same distance. To line of reflection. But on the other side. Oops. Let me put that in the right spot. Other side. All right. So this makes sense because we're going to move top to bottom. So you're going to take your point. You're going to count either up or down to your line of reflection, however many spaces. And then count that number of spaces again on the other side and plop your point down. Let's start filling in this table. We're going to work specifically with these last two columns. Our general rule says that if we were to reflect over the x-axis, we are going to leave the x-coordinate alone, and we are going to change to the opposite of the y because we are moving top-bottom or bottom-top. So my original vertices are here. A used to be at 3, 5. It's now going to be at 3, negative 5. Pause me and fill in the rest of that column and come back for checking. All right, check against my answers. So now we're going to do a reflection over the y-axis, still working with our pre-image. And our rule said when you go over the y-axis, the x becomes the opposite because you're moving left or right, and the y is unchanged. So this 3 is going to become a -3, and the 5 remains unchanged. I want you to pause and fill in the rest of that column and come back when you're ready for checking. Here are my answers. In order for us to fill in the other two columns, we're going to have to do some graphing. So grab about a sheet of graph paper. I find that when we are reflecting over a line that's not one of our axes, the count and draw method is sometimes useful. And so on your half sheet of paper, I want you to draw your coordinate plane. Remember, that's your x-axis, which is right here, and your y-axis, which is right here. And we're going to plot the following points right here, A, B, and C. Now remember, the first number in the pair is your side to side, or your x-coordinate, and the second number is your up and down, or your y-coordinate. So I don't really have space. My paper is pretty small for me to write my numbers, so I'm just going to put my tick marks here. All right, so A is sitting at over 3, over to the right 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5. I'm going to plot my point. I'm going to call it A. I want you to plot all 3 points on your paper. Pause me while you're working, and then come back for checking. Your graph paper should look like this at this point. Now you'll notice that I drew in a line, x equals -4. It's in pink right there. And that line, x equals -4, just simply means that x will be -4 in any ordered pair on that line. And I want you to reflect your pre-image over that line. So what you're going to do, let's take A in particular. You're going to count. It is 1, 2, 3, 4, 5, 6, 7 spaces from our line of reflection. So our new letter A, or A prime, is also going to be 7 spaces from our line of reflection, and it's going to be called A prime. 1, 2, 3, 4, 5, 6, 7, and my arrow's kind of in the way, but this is A prime. So you are going to take B, count the number of spaces to your line of reflection, then place it that same number on the left side. Do the same thing with C. Pause me while you're working and come back when you're ready for checking. Your graph paper should look like this at this point. Now you're going to notice that I have a green line, and this is y equals -2 right here. That's going to be our horizontal line of reflection, and I want you to reflect your pre-image, remember mine is blue, over this green line. And so I'm just going to pick B. And so B is 1, 2, 3 spots above the line of reflection. So B prime is going to be 1, 2, 3 dots below. I'm going to call it B prime. I want you to reflect all 3 of your points over the line y equals -2, and you can pause me while you're working. So now your graph paper should look like this. As we're looking at your graph paper, we can go ahead and start filling in our chart. And so our first reflection was over x equals -4. And so if we look at point A prime, it ended up at negative 11, positive 5. Point B prime ended up at negative 10, positive 1. And C prime ended up at negative 13, positive 1. And I just want to point out something interesting. We reflected over a vertical line, but the most famous vertical line is the y-axis. And our rule said, leave your y-coordinate alone. And look what happened. We left our y-coordinate alone. The other thing I want to point out, simply because I'm a math nerd, is our x-coordinate. It went from 3 to negative 4, which is a change of negative 7. If we were sitting at negative 4 and we wanted to change negative 7, we'd be at negative 11. Or if we went from 2 to negative 4, that's a change in negative 6. If we were at negative 4 and we changed by negative 6, wouldn't we be at negative 10? So there is some mathematics, but I still think the count and draw method is a little easier for us. All right, reflection over a horizontal line. Let's get this filled in. So this one, A triple prime, ended up at 3, negative 9. B triple prime ended up at 2, negative 5. And C triple prime ended up at 5, negative 5. Of course, our most famous horizontal line is the x-axis, where we left our x-coordinate the same, and again we left our x-coordinates the same. And if you're a math nerd, you'll figure out that there is a mathematical reason why we ended where we did, but our count and draw method helps us visualize it a little bit better.